All right, we're moving on to 5.2. 5.2, it says we already know that by definition a parallelogram has two pairs of opposite parallel sides. We are going to investigate other properties that all parallelograms have. So it says look at the parallelogram to the right. Note some properties that the parallelogram seems to have based on simply observations. Specifically, look at the diagonals, opposite sides, opposite angles, and consecutive angles, angles that are one after the other in the bottom diagram. Note what properties that you observe. Opposite sides appear to be congruent as well as just parallel. Opposite angles look to be congruent. Consecutive angles look to be supplementary, meaning they add together to be 180 degrees, and the diagonals look like they cut each other in half, so they bisect one another. Knowing that by definition both opposite sides are parallel, justify mathematically why the consecutive angles must be supplementary. Well, they are SSIAs, and SSIAs, when you have parallel lines in a transversal, must be supplementary. So it says consecutive angles are all same side interior angles. The next one says, given that by definition the opposite sides are parallel, use colored pencils to note the pairs of congruent angles. So it's going to be the alternate interior angles should be congruent. So you have the blue and the blue, and the red and the red. And then it says, explain how you can use your understanding of congruent triangles and CPCTC to prove that the opposite sides of the parallelogram must be congruent. You can write a full proof or simply organize your thoughts. So in addition to the blue and the blue and the red, you also have the reflexive property. Therefore, those two triangles must be congruent by ASA. And since they're congruent by ASA, then their corresponding parts are congruent. So the left and right must be congruent by CPCTC, and the top and the bottom must be congruent by CPCTC. This is kind of how we're going to be using proofs moving forward. We're not making like full proofs normally. Sometimes we will just to keep them fresh in our brain, but most times we're just going to be able to justify things by going over and thinking through a proof. It says use the same argument to prove that the opposite angles are congruent. Well, one way you could use the opposite angles are congruent. These two triangles would be congruent, so those opposite leftover angles that haven't been colored are going to be congruent by CPCTC. Also, you can see that the bottom left and the top right triangles are both made by the red and the blue angle. So since they're both the red and the blue angle, and the red is congruent to the red and the blue is congruent to the blue, then you could say that those angles are going to be congruent because they're both made of the same two things. Another way you could have said the non-colored angle is congruent to the non-colored angle would be the third angles theorem, which we learned a long time ago. Now the deal here though is if you're going to use CPCTC, you'd have to do two different proofs. You would make a diagonal going from bottom left to top right, and then from top left to bottom right, as you can see here. And once you have those two pairs of congruent triangles by ASA, then those leftover angles would be congruent by CPCTC. Now next says, knowing that the opposite angles of a parallelogram are parallel, use color coding to show all pairs of congruent angles. So I have light blue and light blue, purple and purple, dark blue, red and red, dark green, and light green and light green. Those are by AIAs, also by vertical angles theorem. So that is how all of those angles would be congruent. It says, now note all the sides that we know must be congruent based on what we discovered on the previous page. Well, we learned that the opposite sides must be congruent, so top and bottom would be congruent, and left and right would be congruent. Now that we have that, how can you use all this information to mathematically justify that the diagonals bisect one another? Well, if you just look at the left triangle and the right triangle, you have two angles and then a side, so by AAS, those two triangles must be congruent. And if those two triangles are congruent by AAS, then you know that their parts are congruent, which basically means those diagonals are going to be going through this, they're going to cut each other in half because they're going to be, the different parts are congruent. Take a look over, I don't think you can see my cursor, but the bottom right there, it shows the parts that must be congruent by CPCTC. And since those are congruent by CPCTC, they must be cutting each other in half. Now, putting all this together, if you know a figure is going to be a parallelogram, you know by definition both opposite sides are going to be parallel. But beyond that, you know both opposite sides are going to be congruent. You know both opposite angles are going to be congruent. You know that the diagonals bisect one another. And you know that all consecutive angles must be supplementary. And our justification for that is either using CPCTC or using something like AIA or the third angles theorem or SSIA theorem. Now looking at this, it says use your understanding of the properties of parallelograms to solve the following. Explain what property used. I intentionally put a bunch of information you did not need to know in here. So on the first one, it looks like they're dealing with opposite sides, and we know those are congruent. They also have opposite angles being congruent, but I think that that's just to mess us up. If we set up equations with both opposite sides being congruent, the top and the bottom, you can solve that equation because there's only x's. The left and the right you can't solve until you find out what x is. And the property you'd be using here would be both opposite sides are congruent. Now the next one has both opposite sides are congruent, but that doesn't seem to be where the variables are. The variables are with consecutive angles, and consecutive angles have to be supplementary, so they're going to add to be 180 degrees. So you add them together and set equals 180 and solve. All consecutive angles are going to be supplementary. The next one has both opposite sides being congruent, but there's no variable in there. We also have the diagonals cutting each other in half, and I'm able to use that to say 3x must equal 6, and I can solve. And our reason we're able to do this is for a parallelogram, diagonals bisect one another. And the last one, it shows us that both opposite sides are congruent, but we don't need that because there's no variable. We also know that opposite angles are congruent, and that is helpful because that's where the variable is. So we could set those equal to one another and solve, and both opposite angles are congruent is the property that we'd be using. Now for your homework. Beyond both opposite sides being parallel in a parallelogram, what other 4 properties have we discovered? We know both opposite sides are congruent, both opposite angles are congruent, diagonals bisect one another, and all consecutive angles are supplementary. If the midpoint of one diagonal is 4, 7, what is the midpoint of the other diagonal going to be? What property justifies this? Well, it's also going to be 4, 7 because they cut each other in half, which means they go through each one's midpoint. So if one midpoint is 4, 7, the other one would have to be 4, 7 as well because the diagonals bisect one another. Now, just to keep things fresh in your mind, here is one proof. We talked our way through it in the notes, but we're actually going to do it. So the figure MNVK is a parallelogram. That should say given underneath. It didn't show up for some reason. And if it is a parallelogram, then both opposite sides are going to be parallel by definition of parallelogram. We have that. Then you have 1 is congruent to 4 and 3 is congruent to 2 by AIA theorem. You have the reflexive property. Once you have that, then you know that triangle MNK is going to be congruent to VKN by ASA. And once you have that, then you know that the top and the bottom would be congruent by CPCTC, and the left and the right would be congruent by CPCTC. You can see how we're using our triangle congruent tools to be able to solve for things that we want to know. Number 4, use the properties of parallelograms to solve for the variables. Also explain which property was useful. There's a lot of irrelevant information that you do not need. Assume all figures are parallelograms. So on this one, where the variables are going to be consecutive angles, and we know that they are supplementary. So I can add them, set equal to 180, and it would be consecutive angles or sup. The next one where the variable is going to be the diagonals bisecting one another. So you know that the 3x has to equal to 6, and that would be diagonals bisect one another, and you get x equals 2. On the next one, we are looking at this, and it appears that we're dealing with opposite angles being congruent. All the rest of the information is kind of worthless. Just trying to see if it tricks you or if you know to ignore it. So 3x equals 60, and when you solve, you get x equals 20. And the next one would be both opposite sides are congruent, is what we'll use. One of them, when you set it up, you have 2 variables, so you can't solve. But you could solve the other one for x first, sub it in, and then you'll be able to solve for y. All right, hopefully that made sense. Once again, the main thing here is that by definition, both opposite sides have to be parallel, but there's also 4 other properties that you can use. Both opposite sides congruent, both opposite angles congruent, diagonals bisect one another, and all consecutive angles are going to be supplementary. Thanks for watching.